Hello everyone, Namaskar. So I hope you are fine and enjoying your studies at the moment. So we are going to solve one more question from Fourier transform. We have to find the Fourier cosine transform of fx, and fx is different for different intervals. First of all, the Fourier cosine transform of f of x, which will obviously come out to be a function of s. So it is written like sorry, it will be subscript will be c, so like this, and it is calculated as 0 to infinity f of x cos sx dx. Fine. Okay. So now fx, because fx is defined different for different intervals, so we'll break this integral into three different parts. So the first one will be from 0 to half, and in this interval fx is x, so x cos sx. The second interval is from half to 1, and in this interval it is 1 minus x cos sx. Third interval is an easy one indeed for us. It is greater than 1, so 1 to infinity. Their fx is 0, so 0 cos sx dx. You all know that this will become 0. Now focus on the first and the second one. So according to Eilert, this will be our first function, second function, first function, second function. So let's move on with the integration by part. So Fourier cosine transform will come out to be, it is from 0 to half. First one is x, second one is cos sx. So first, as it is, integration of cos sx is sine sx divided by s, minus integration of derivative of x is 1, integration of cos sx is sine sx divided by s, again integration, and this one is from 0 to half, I think. Yes, it is. So 0 to half. Then I have the second one, which is plus, again 1 minus x as it is, that of cos sx is sine sx divided by s, minus integral of derivative of 1 minus x is minus 1, so this will make this plus, integration of cos sx is sine sx divided by s dx, and this one was the next interval from half to 1. We'll have to do some more work. So this one is, first integrate this and this, so you'll get x sine sx by s, and this one is integration of sine is minus cos, so this will make this plus cos sx. One s will come down, one s is already there, so s square, and this goes from 0 to half, plus 1 minus x sine sx divided by s, integration of this sine will be minus cos sx, one s will come, one s is already there, so s square from half to 1. So now it's important part of the question, because we have to put the limits now. So when you will put the limit as half, so sine s by 2 plus cos s by 2. When you will put 0, because of x it will become 0. When you will put 0, this will become 1 upon s square, because cos 0 is 1. And here, when you will put 1, the first part will become 0, because 1 minus 1 is 0. From the second part, you will get minus cos s by s square. When you will put half, 1 minus half is half, and for lower limit you get a negative sign, so half sine s by 2 divided by s, and here 1 minus sign from the lower limit, 1 minus sign here, so plus cos s by 2 divided by s square. Fine. So is anything getting cancelled? Let's see. So as I can see, cos s by 2 by s square is coming twice. Sin s by 2, this one is getting cancelled. Half times sin s by 2 by s minus half times sin s by 2 by s, and cos s by 2 by s square is coming twice, and yes, so 2 times cos s by 2 by s square k, and only I have one term is this also, cos s by s square and minus 1 by s square. Okay, so let's see whether any trigonometry will be used. So what sort of trigonometry I am looking for? I am looking for the first and the last term. And which formula I am looking for? I am looking for cos 2 theta is 1 minus 2 cos square theta. Okay, fine. So will this format be used? Okay, but square term is not there, so I don't think that formula will be used here. Okay, 2 cos theta minus 1, 2 cos theta minus 1. So it's better leave it to this particular point only. Okay, so although we have done a lot of work in this question, not a lot of work, just one page, but yeah, we need to know what is the formula for Fourier cosine transform, that is 0 to infinity f of x cos sx. Now we broke that into 3 parts because fx was different for 3 different intervals. For 0 to half it was x, for between half and 1 it was 1 minus x, and for x greater than 1 it was 0. So we got 2 integral, we further solved those 2 integral and finally got the final Fourier cosine transform result, which was in terms of s. So that's it from my side. Do watch my playlist on Fourier series, Fourier transform as well, for more such question. That's it from my side. Thanks and have a nice day.